Videos of the kind of pre-dissection, so to get people oriented. Do you remember that? So you might show that there's a video link. Click here for a video dissection of the brain, and so it just says what's anterior, what's posterior, major structures. These brains have the pituitary gland. That's this right here, and roots of that's trigeminal. And a portion of the dura mater. So this is dura mater, separating where the pituitary would sit. I know my big hands are in the way. Sit in the sella turcica, right? And they have to cut around the dura mater, otherwise you do like this and pull off the pituitary. So they're going to have to do that. They're going to have to pull off the pituitary, identify this dura mater, and break some nerves. Yeah, unfortunately, I didn't do that well. I should have left that on there. All righty. So, olfactory bulbs sit in the cribriform plates, and then olfactory tracts. The optic nerves are cut. You see a little bit of a stump here, and the optic nerves come and cross at the optic chiasma, and then these are optic tracts heading back towards the thalamus. This is where the pituitary did lie. And so this hole is actually, you see that there? That's actually the passageway that carries hypophyseal portal veins down into the pituitary. This little hole right here. That's not something they have to identify, but because I know you guys remember the hypophyseal portal veins, I thought you might think that was interesting. This big hunkin' thing, so this is a good way to kind of get oriented. So I always go 1, 2, 3, right? This is 3, this is ocular motor, so that's a big nerve that controls the muscles that move the eyes. Trochlear is going to be very tough to find. So we've got some arachnoid mater here. Oh, there it is. That's the trochlear nerve. So that's 4. And now it gets kind of messy, right? Big trunk of 5 that I pulled off. And then here's 6 on this side. And I pulled it off completely on, where is it now? Here. Yeah, so I should have been a little bit more careful pulling this off.
Wait, where's 5?
5 is this big stump right here.
Okay.
Yeah. And then 6 lying over the pons. And that's all you can see reliably. Everything else is just a mess.
So on the sheep brain, when we do their checkoff, go through the nerves that we can see and then major structures on that, or what else would we ask them on the?
On the whole sheep brain, so they should have a whole. You should have a whole sheep brain for nerves, because it's a little bit easier to identify nerves. You can also have the human brain, and then they're going to dissect this way to identify. Do you want me to go through that real quick?
Sure.
Yeah.
Okay. All right. So the trick here is to cut through arachnoid, which actually I should probably just do with the probe. So the less cutting, the better. So that when you do cut, you are cutting in one fell swoop, trying not to pick up your scalpel. Trying to stay in the middle. And then we're a little. there. So these don't look very well preserved, actually. That's kind of odd. Okay, so corpus callosum and fornix. Can't, well, kind of on this side. A little bit of septum pellucidum there, so I didn't give it an absolutely central cut. That's not something they're going to be asked to identify anyway. So corpus callosum, fornix, going into the cerebral hemisphere, lateral ventricle on both sides, right? And then this and this is the very large intermediate mass of the thalamus or interthalamic adhesion. It looks really large because the rest of the brain is so small. And the space around that, which is really tough to see in this, is the third ventricle. That's going to be easier to point out on the human brain model for sure. And then the connection with the third ventricle with the cerebral aqueduct, which you kind of see here, but I just didn't do a very good job of cutting. Yeah, so cerebral aqueduct can kind of make it happen. Make it so. Into the fourth ventricle. I've got some good choroid plexus in this fourth ventricle. That's this stuff here for cerebral spinal fluid manufacture. Have good corpora quadrigemina, superior colliculus, inferior colliculus, right? So together they make the four little round bodies. 4 reflex centers for visual and auditory reflexes. Pons, medulla. I don't think I mentioned this before. Move. Oh yeah, I didn't even get close to center. Gemini. I'm trying to show you the mammillary bodies here on either side of that hole, that opening, which is part of the hypothalamus. And we know that that's hypothalamus behind the optic chiasma, right? Behind the optic chiasma and below the thalamus, that's thalamus. Behind the optic chiasma and below the thalamus, that's hypothalamus.
So it's really small.
It's pretty small, yeah. Yep, and it's going to be right above the pituitary where we took the pituitary off. Cerebellum. What else is on that list? Pineal gland, but I am not sure that I think it's underneath this mass of vascular tissue because I didn't cut it down the center. I think it's actually in there. But the pineal gland is also on the human brain model, and it's pink because it has such a good blood supply because it's an endocrine gland.
Gray matter in the spinal cord? Did they do
Yeah, we're not going to really see that well here. We do see the central canal on the spinal cord, though. But it's not going to really appear white or gray very well in this dissection.
cerebral peduncles?
Oh, peduncles.
Peduncles.
So I kept the cerebral peduncles in there and the cerebellar peduncles, just because if you think about what they are the white matter connections between the cerebrum and the rest of the brain stem. We talk more about them in lecture, because unless you just start whacking away at the brain, you're not going to see them. But the peduncles are the white matter, like the cap of a mushroom. If you pulled the cap of a mushroom off, you would break all those filamentous mushroom hyphae. And so there's similar white matter connecting the brain stem to the cerebrum and white matter connecting the cerebellum to the brain stem as well.
So what makes a peduncle a peduncle?
A peduncle is a stalk-like functional and structural connection between those big developments, the cerebellum and the brain stem and the cerebrum and the
So
brain
they don't
stem.
have like a structure to them then?
They're white matter.
White matter. Okay.
Yeah.
Besides that, just like lobes and sulcuses and
Yeah.
fissures and
Yeah. Which I wouldn't test lobes or, I mean, other than the, saying this is frontal lobe and this is occipital lobe. But I mean, because it doesn't have the same kind of architecture as the human brain, it's pretty tough. But definitely do that on the human brain model. Definitely point out the central sulcus, the precentral gyrus, the postcentral gyrus, the different lobes. Remind them that it's good to know your skeletal anatomy because that helps with everything from this point on. Yeah. Okay, any
So when they're
questions?
looking at it, try to find whatever they can, but then for the actual checkoff, just do cranial nerves and
All the things that I pointed out, you can test on the sheep brain, and we could still, corpus callosum, white matter or gray matter, thalamus, white matter or gray matter. So they have to know that rather than recognize it because it looks like white matter. I
Yeah.
mean, there's a lot of white matter in there, but it's mostly gray matter because there's a lot of synapses in there. Arbor vitae is on there as the white matter of the cerebellum. That's the only clearer distinction between white and gray matter in the dissection. Now they're kind of weird. Well, they're kind of crumbly. It's kind of a weird texture.
Question on the online when we do our reviews
Yes.
on Pearson, there's a calendar. Do we have to follow like the calendar?
No, so those quizzes they have a due date because I have to put a due date in there. So I picked a due date a little bit before the assignment is actually given in
Oh,
lab.
okay.